Welcome back. In our previous video, we took time to explain the Cartesian plane, an environment in which our linear graphs will live on. And we explained that it is made of these boxes which we called the grids, and also it has these reference lines that we called the axes. The first line that is horizontal, which we called the x-axis, and the second line, which is vertical, which we called the y-axis. But in essence, we were able to even place basic vertical and horizontal line right on this plane. Otherwise, ladies and gentlemen, today we want to be able to do complex things with these linear graphs, because what we had last time was just basic lines, which does not really get into the functionality of the linear graphs. But these linear graphs has much more to offer than just the basic vertical and horizontal lines, which we're going to look at today. But the graphs, in their actual sense, they relate variables. In other words, they relate things. That's why we have the x-axis and we also have the y-axis. These two will be related by what we call the coordinates. And a coordinate is simply a point when two lines meet. We had basic horizontal lines and basic vertical lines, and a point at which these two can meet is what we call the coordinate. It will be formed by the x-coordinate and the y-coordinate. And it is also expected of you to be at least able to tell what are the coordinates. In other words, what are the x and the y values that exist at that point. Let's have an exercise where we will come up with coordinates that are existing on the points that I'll be pointing out, of which I will do a couple, then I will have you do with me the next three. Let's start with the first one. At this point, what is the x value and what is the y value? And please notice, the order is important. A coordinate is made up of x and y value, and always x comes first before y does. Otherwise, don't mix this order. A coordinate will be made up of the x value and the y value, and the x comes first before the y does. Otherwise, let's go to our coordinate and let's see the actual value that form this coordinate. So in the x-axis, you see that I have a 3, and in the y-axis, you can see that I have a 2, meaning that this point is made up of 3 and 2. The coordinate at this point will be 3 and 2. Otherwise, we'll go to the next one. Let's go to this coordinate. As you can see, the x value at that point is actually a 2, and the y value at that point is a -1, meaning that the coordinate at this point is 2 and a -1. Let's go to the next one, and it's your turn now. What is the coordinate at this point? I'll give you a second to give it a try. Did you just say -4, -2? If you did, congratulations. You now understand how we come up with coordinates. Let's do another one. What is the coordinate at this point? Did you just say -4 and 1? If you did, congratulations. You got it right. Let's do two last ones. What is the coordinate at this point? Did you just say 0 and 1? If you did, congratulations. In the x, we have 0, and in the y, we have a 1, making this coordinate 0 and 1. Please don't mix up. X always comes first, then follows the y. Let's go to the last one. What is the coordinate at this point. Congratulations if you said 2 and 0, because in the x here we have a 2 and in the y we have a 0. If you struggled to do this exercise, please take time to try and understand how this works, since everything we are going to do will be revolving around this very same concept. Otherwise, let's go to the next piece. This will be the equation that will govern how the x coordinates and the y coordinates will be relating to each other if we are talking about a linear relationship or a straight line relationship. Otherwise, this will be the x coordinate and this will be the y coordinate, and we'll be able to represent them on the graph. This y and this x are those very coordinates, and this m will represent what we call the gradient. I'll explain what the gradient is in a second, and also this c will represent the y-intercept, which I'll also explain in just a minute. But for now, to keep things in perspective and to keep them very less complicated, I will not focus on the c, I will only focus on the m, so that we're able to keep things as simple as possible. Let's say that I want to buy socks. It means that I'll need to have money, and I will be able to obtain socks with the money. And let's take all these numbers in the x-axis to be my dollars that I have, whereby 1 is representing $1, $2, $3, $4, and so forth. And let's say that a pair of socks is costing $1. What it means that if I have $1, I can purchase 1 pair of socks. And if I have $2, it means that I can be able to purchase 2 pair of socks. If I have $3, I'm able to purchase 3 pair of socks. And if I have $4, I can also be able to purchase 4 pair of socks. In other words, you can see the relationship, that the number of socks that I'm able to obtain is dependent on the number of dollars that are in my wallet. This forms a relationship that looks like this, whereby I have the number of dollars that I have directly relating to the number of socks that I can actually obtain. Wow, interesting, isn't it? But now, that's not the only case that we can have. Sometimes you have 1 pair of socks costing $2. In other words, with $2, you can only be able to get 1 pair of socks. What it means is, with $4, you can be able to purchase only 2 pair of socks. And with $6, you can be able to purchase 3 pair of socks. In other words, still we have a linear relationship. It's straightforward, but it's not a 1:1 relationship, but instead it's actually 1 pair of socks that is actually costing $2, which makes the line to look different from how this line was looking. But also we can have a situation whereby we can have a pair of socks costing $0.50 or 50 cents. What it means is, if I have $1, I can actually purchase 2 pair of socks, which means that if I have $2, I can be able to get 4 pair of socks, and the relationship will go just like that. And if I can try to connect these dots, you can notice that I can still have a straight line relationship, but now the relationship is a little bit more steeper. What is causing that? That is the effect of what we were calling the gradient. Otherwise, let's go and show this on a graph. I'll draw my first graph using GeoGebra, and I'll make my m to be equal to 0, meaning that on my y is equals to mx as we are looking at. In this case, my m value is going to be equal to 0, so I'll have it as 0, and of course I'll put an x, and there I have my equation. And as you can observe, when my m is equal to 0, my graph is 0 steep. In other words, it's just flat and it does not have any steepness at all. And I'll increase the value of my m by a 0.1, making my y equal to 0.1 of cos of x. And notice that now my graph is becoming a little bit steep. The 0.1 value of m that I've placed makes my graph to be a little bit steep. And I will increase the steepness a little bit and place my steepness to be equal to 1. And I'll have it as y is equal to, and of course, 1x. And notice that now my graph is becoming a little bit steep. It's even steeper than when I had a slope of 0.1. I have y is equal to a steepness of 2. And notice that my graph is now becoming quite steep. And think of it this way. Which road would you prefer? The one way you have to climb through this mountain, or you have to climb through this mountain, or you have to climb through this mountain? If I were you, certainly I would prefer the flat surface because the gradient is a bit small. But in other words, as you make your value of m to be bigger, you are having more steep graph. In other words, that's how the m value influences the steepness of your curve. Let's have another one. Y is equal to 10x. Now my m is way big, and you can see that this mountain is becoming more steeper to climb. And let's have another one. Y is equal to 1000 of x. You can see that now it's very, very steep, super steep. So you can see that as my gradient becomes quite big, my graph is also becoming quite steep. Something interesting also happens as my value becomes quite small. So I will have it so small that now it's even taking negative values. I have y is equal to negative 0.1, and you can notice that now I actually have a negative slope. Why is it a negative? I'm not climbing the ladder, but instead I'm actually going down the ladder. And let me have it also when y is equals to negative 1 of x. Notice that I'm now even going down more. In other words, as you have less and less values of your m, let me give it a negative 2 and let's see how that looks like. It starts to decrease even in a very steeper way. Let's have it when y is equals to negative 10x. And you can notice the relationship. If I come and give it a negative value, instead of the steep to actually be increasing, it starts to decrease. You will start to have a negative slope. And I'll illustrate this right here. Let's say that in green is your ball. You can notice that your ball will have a difficult time climbing this line if it is going to increase in steepness. But if we make this steepness to go the other way around, it will be very easy for the ball to roll down. In other words, it is going to go down. Therefore, ladies and gentlemen, I now expect you, when you look at a steep that looks like this, to tell that this is a positive gradient. Why? Because you have an increase in this gradient. And when you have a line that looks like this, you should tell that this is a negative gradient. Why? You have a line that is going down. So this is going up, this is going down, this is going up, this is going down, this is going up, this is going down. This is a positive gradient, this is a negative gradient. This is a positive gradient, this is a negative gradient. Hopefully you have been able to understand how the M can influence the steepness of your line. The greater it is, the more steep of a line you're going to have. And you have even understood how your M can even influence the direction or the orientation of your line. In our next video, we are going to go and take a look at how our C value can affect even the position of this line. If you're finding value in these videos, take a moment to give a like. And if you think that this stuff is very interesting to you, please become part of a family by just hitting that subscribe button. And of course, if there is a friend or a colleague you think that might benefit from this material, do not hesitate to share this material with them. Otherwise, this is Motsi, your favorite tutor, signing out.